All right, guys, welcome back. We are moving and continuing on, trying to finish our unit up soon. Unit 2, all about Earth's internal structures. And the other day we discussed on page 17, we went over the different types of convergent boundaries, right? So again, I'm just going to expand this, show this a little bit. Again, ignore me in the background, but do look at our sheet here, right? So we convergent boundary types. We had oceanic in our third column. In our second column, in our first column, my bad. Second column, we had oceanic continental. And then third column, we had continental. And then we proceeded to fill out these three sections here on page 17. I have these pictures if you wanted to get a closer view. Feel free to pause the video as you see fit. But yeah, so again, I realize that the videos do show the words the right ways to where you're able to read them. So I'm just going to kind of do that, make things a little easier for us to kind of follow along as we go along, right? But let's go ahead, minimize my screen, look at the Go Blue for today. The vocab is due tomorrow, guys. We do not have a video lesson tomorrow. We are going to instead, I'm going to have you guys focus on your unit quiz. Going to be 15 questions, multiple choice. And you've got a notebook check to submit as well over the weekend. So make sure you take those things, complete those, because looks like that will be the last few assessments of this 9 weeks, because the quarter ends next Friday. We got to make sure, I got too many of us have some stuff not turned in and missing. We've got to get those things at least completed for some partial credit, okay? So again, in order to maximize our grades, we got to get rid of those zeros. I've got to update some grades here as we move forward. Our questions though, guys. Number 1, blank convergent boundaries create land volcanoes, while blank convergent boundaries create island arc volcanoes. All you got to do is look at page 17, right? So the first one is land volcanoes. That's the second column. That's going to be, okay, oceanic continental. And then our second one is going to be oceanic. Okay, so again, we're talking about crust combinations. What are the two types of crust? Oceanic and continental. Got to know the differences. Also, guys, question number 2. Sorry if you weren't able to pause and you saw the answer there. Tell me the two types of crust for letter A. B, tell me which one is more thick. C, which one is more dense. D, which is deeper. E, what earth sphere is the crust. And F, what is subduction? Okay, so we got to know all those topics, got to know those differences between those different crusts, right? So number 2, again, pause if you'd like to, but otherwise we're going to go through it. Again, we already know. We saw it in the first question. A, oceanic and continental. Oceanic and continental, guys. B, continental. C, my bad. B is continental. Continental is going to be more thick. It covers more area. Oceanic, letter C, is more dense. It's more compact. Why? Because it has the ocean sitting on top of it, right? Okay. Oceanic, letter D, guys. D is oceanic. Again, that is going to be deeper. The oceans are always more deep than the continents. That's what I always say for us to help remember it. E is the lithosphere. Again, the crust. It is mesolithosphere. Lithos, all the rock and all the plates, right? And then lastly, what is subduction? It's when one plate does what? Goes beneath the other. One plate goes beneath the other, okay? That's a little recap for number 2, a little important stuff we need to know as we move forward, right? So again, know those by heart because we have our quiz coming up. Okay. These are, ignore those. I may have us do a separate writing assignment. Go ahead, guys. Again, 18 through 19 are going to be faults. We're going to go over faults today. It's going to be kind of like our boundary types we've been going over, but instead it's going to be much shorter, much simplified stuff. So what I want you guys to do before we move on, we're going to go to that another day, the steps to surviving. What are the 6 steps to surviving an earthquake? Yeah, go ahead. I think this is important stuff. Well, let's see. Was there something in the video I wasn't? And you know, it's fine. It's how to survive, and we need to know how to survive earthquakes. And we know earthquakes common in Florida, but not common in Florida. But I think it'll be important to know. So, what are the 6 steps to surviving an earthquake, guys? I'll post this video online. You just need to make sure that you copy this to page 18. Copy this to page 18. Okay. Oh, I can't give away all the answers there. So, things to key on, things to know. All right. All right, so let's go ahead and go to faults. Types of faults. Here we go. Let's see if it opens up. It should open up because here we go. All right, so what I'm going to have you guys do is, let's see. Well, let's do some questions here. Let's go ahead and do some questions. Okay. So which type of plate boundary is primarily cause of land, volcanoes, and mountains? We just saw that, guys. That's going to be A, B, or C. Divergent, convergent, transform. It's going to be B. Convergent plates coming together. Okay. Again, that's going to cause most likely our land volcanoes. A prime example of this plate boundary would be the San Andreas Fault in California. A, Rift Valley. B, convergent. C, divergent, or D, transform. Pause video, see what you think you know. And it's going to be D, transform. D, transform. Okay. All right. We're going to go ahead and move on, guys. I'm going to have you guys set up page 19, and here's what we're going to do. Okay. Oh, I wish I could expand. Could I expand that some more? I guess not. Okay. On page 19, title it Fault Line Types. Fault line types right there. You're going to have a total of 3 columns. 3 columns. In our first column, we're going to call that normal fault. Okay, normal fault. And you're going to have the plates, one plate going down, moving down. Okay, again, normal fault. Pause video as you see fit. Again, have the information on the right, information on the right. Our next one is going to be thrust/reverse fault. And you're going to show one plate moving up. It's just the opposite. Okay, so thrust/reverse fault. That is our second one. And our third one is going to be strike-slip fault. Strike-slip fault. Plates moving horizontally. Again, the word at the bottom says move horizontally. Go ahead, pause video as you see fit. We're going to have 3 columns. Okay, 3 columns on the right, left side, or on this side, you're going to have the fault illustrations, and on the other side, you're going to have the details that you'll fill in here with me. Page 19, page 19. Fault line types, fault line types. Okay, let's go ahead and minimize the screen and move on. Oh, I forgot to show the video that goes over how to survive an earthquake, and I've got that right here. Okay, again, you've got to watch all of this on your own. I'm going to show you guys just a minute of it, right? Stuff we kind of already know, but stuff that we need to know in case some of you guys move out to the West Coast. You get more earthquakes in California, Alaska, Hawaii, Oregon. Maybe something to be aware of, right?
Due to the tectonic plates on the Earth's crust, the plates are constantly rubbing against each other, and when these bumps are violent enough, a seismic wave will happen, causing an earthquake. These can range from a slight tremor to a shake so big it will take out entire buildings. So if you do find yourself in this situation, what can you do to survive?
And you guys have to watch the rest of it to find out, again, the 6 steps to surviving an earthquake. Very important stuff that can impact our lives, obviously, and I wanted you to watch it. But let's go ahead. And, oh, there's another video of me from the other day. Put some pizza there. Okay. Let's go ahead and talk about normal faults, guys. Normal faults. Again, go ahead on page 18, write what's in red here. A fault is a fracture or system of fractures in the Earth's crust. Just to define it, I figured if we got to know types of faults, we probably should know what a fault is. Am I right? So again, just a break and opening in the ground. Okay, any break, any fracture, any opening in the ground, that's a fault. Let's go over our first type. Again, these are not colored in any sort of way, but they're not in red, but you do need to write these down. So I'm just going to go ahead. You know what? I'm just going to go ahead, mark it in red, because why not? It helps you guys, helps me make things better for you. Nope. I'm going to try to wrap things up here in a few minutes, guys, in a few minutes. Sorry for the slight delay. I got 10 minutes left in the 6th quarter, guys. It's just busy day. So if I don't get this posted in 6th period, my apologies, guys. It'll be posted after school today. I'll have to make another announcement. Just trying my best. Okay. Oh, nope, don't want that. Oh, that's showing answers. It's just not my day today, guys. Okay. Our first one is normal fault. It looks simple, guys, but there's a lot of multiple choice questions that I can use just from these fault categories. So normal faults, guys, again, we should be on the right side of our sheet, page 19. Again, page 19, or my right side. I guess maybe the video shows differently. This occurs at divergent boundaries. You've got to know what type of boundaries occur with each of the faults. Okay, so divergent, and when plates move apart, what's going to happen with those 2 plates? Well, one of them's going to slip down. One of them's going to slip down. That's the key thing to know there. And then we've also got to know the forces that are associated with each of these faults. Okay, so those forces include, for this, normal fault is tension. I know a lot of people miss this question on the test. They think tension, oh, I got tension in my head. And, it's like, oh, I got pressure. It's building up. Well, for this, it's not that situation. You're talking about stretching something. Anytime I pull something apart, like if you're pulling rope, like a tug of rope or whatever they call it, anything that's being pulled apart is having tension built in it, building up in it. Okay. And then I've got a interesting California earthquake video from a news station to show as well. I'll post that on. I will post that onto Canvas as well. I'm just going to show you a little glimpse of it. Ignore all the advertisements, guys. I'm trying my best to, again, it's not, sometimes I can't control it, right?
The Colgate Optic Way Overnight Whitening Pen
Colgate's not the worst
removes
advertisement.
15 years of stains in just 1 week. Easy and effective.
First, though, we want to get to Southern California on alert this morning after getting hit by the largest earthquake there in 2 decades, sparking more than 160 aftershocks. ABC's Eva Pilgrim is in Trona, California, starting us off with the very latest. Eva, good morning.
Good morning, Whit. We are very near the epicenter of this earthquake here, and you can see the damage it's done here in the story. I just want to walk you through it. All of these bottles basically knocked around. Many of them.
So again, watch the rest of that. It gives you a great glimpse. I showed you guys the volcano news reports. So now we get a glimpse of if you live in California, you live on the West Coast. Hey, every once in a while you get some earthquakes, and this is kind of a glimpse of what the impact of that is like, right? All right, let's go ahead and finish our last 2 faults of the day with a little practice question here. Which contributed least to the theory of plate tectonics? A, Earth's climate, B, Earth's rotation, C, fossils, or D, rocks? This is a question that got a lot of people. Pause the video, think about it. Our answer is going to be B, Earth's rotation. Again, Earth's spin has nothing to do with continents moving, okay? Gives us no evidence for continents moving. Again, the spin of the Earth, nothing to do with it. No evidence, right? All right, second one, guys, thrust reverse. It's just the opposite of normal, okay? So instead of divergent, we get convergent boundaries, okay? The plates going together. Instead of the plate moving down, now the plate is moving up, okay? Instead of force being pulled apart, now we have force going together. That's compression, okay? That's compression. Pushing things together. That is thrust reverse. That is thrust reverse. And our last one, guys, is going to be strike slip. Strike slip. And we're at the bottom of this right here, right? Okay. Occurs, well, by order of subtraction. What's the last boundary available? It's going to be transformed because our plates are now moving horizontally. They're moving side to side. Just like on a cold day, you're going to rub your hands together side to side. That's that friction. We also call that friction shear stress. We went over compression. We went over tension. Last one is shear stress. Again, the force of 2 objects slipping or friction going together. That concludes our lesson for today, students. I'm going to post this to Canvas hopefully before the break ends. And again, you got to get that video analysis from yesterday done. You got to get the vocab done. You got to take care of the notebook check and the online quiz tomorrow as well. So if you have any questions, let me know. Grades should be mostly up to date. I've seen some more assignments coming in today, so I'll try to get to those later after I do ELP today. Otherwise, Mr. Campbell signing out. If you have any questions, always feel free to let me know. Take care, everybody.